Hi everyone, this is Jake, and this is my contribution to this week's discussion. So my question for this discussion is taken directly from WebAssign 4.3, and it's going to be question number 5. The question is, consider the equation f of x equals x cubed minus 3x squared minus 9x plus 6. And it's from the section basically talking about how derivatives change the curvature of the graph and how we can use those derivatives to figure out the important points on that graph. So the first part of the question is going to ask you to find the interval on which f is increasing and decreasing. And you can actually use this method on pretty much every single question that's in this section. So kind of like pay attention to the pieces where it's like kind of telling you what to do, because you can actually apply that to every single equation that this section gives you, and it's pretty formulaic. So what you're going to do first is you're actually going to find f prime of the original equation that it gave you. And you're going to, and f prime for this question is 3x squared minus 6x minus 9. It's pretty easy to find this one with the polynomial. You just basically you find the derivative of each part, very easy. And you have two options here. You can graph it. I find it easier to graph it as I'm doing the problem, because I like to kind of check with the graph, especially if the graph is really easy to read like this one is. You can kind of check the graph and check your work, and it's pretty easy that way. So you're going to graph it, and you're going to equate f prime to 0, and then you're going to solve for x. So here, it's pretty easy to solve for x. What you're going to do first is you're going to basically factor, well, you're going to set it to 0, and then you're going to factor the equation. Here you can do the next step of dividing out 3, but it's pretty clear that the x-intercepts, which is what you're looking for, of f prime, are going to be x is positive 3 and x is negative 1. And you can see that work right here. And so with this information and consulting the graph, you know that x minus 3 or x negative 1 and 3 is where the f prime is going to be crossing over the x-axis. And so with the consulting the graph, you're going to find that it's increasing on the interval negative infinity to negative 1 with 3 to positive infinity, and then that decreasing interval is going to be right there in between those two. And the reason why the graph is really important here is because if the line itself is above the graph, then it's going to be increasing. If it's below the graph, it's going to be decreasing. And you can do this without the graph itself, and you can kind of just calculate the values on either side of the x-intercept. I just find it easier to look at the graph because it's kind of, just visual and easy. Okay, so the next part is going to be section B. And you're going to find the local min and max. And so we've actually done part of this already. You're going to find the x-intercepts that you found for f prime and part A and just basically plug them into f of x. Because we know that those x-intercepts of f prime are going to be significant numbers in f of x. So plugging those numbers in is going to be f of negative 1 equals negative 21, and f of positive 3 is going to equal 11. And it's really important here. You can also kind of consult the graph as well. If it goes from above the graph to below, it's going to be a maximum point or a local maximum. If it's from decreasing, so below the graph or the x-axis to above the x-axis, it's going to be a local minimum. And this makes more sense once you kind of look at it with the graph. And yeah. And then the next part is you're going to find the inflection point. Pretty simple here too. You're going to find f double prime, which is 6x minus x. And then you're going to set f double prime to 0 and solve for x. And so this is pretty easy. F of double prime equaling 0, x will be 1 in this case. And so then you're just going to plug that value right back into our original equation, and then you'll find your point of inflection. And so for us there, it's just going to be 1, -5. And so that's where we know it changes from concave up to concave down, or concave down to concave up. And again, this is kind of where the graph comes in handy. So you can kind of look at that point on the graph and just kind of figure it out from there. Pretty self-explanatory. So from there, we're going to find the interval on which f is concave up and concave down. So once you have your point on the graph, you can kind of see which way is up and which way is down. And for this way, we know that there's only going to be one up and one down because there was only one inflection point. There could be more than one inflection point, so don't, like when you're going on to like other problems that are like this, don't kind of assume that there's only going to be one. So we know that concave up is going to be 1 to positive infinity, and concave down is going to be negative infinity to 1. And I'll go ahead and post my sheets here so that way you can read them a little bit better. I know this angle isn't the best. So yeah, if you have any questions, concerns, thoughts, comments, please let me know.